Have you ever wondered why some electrical systems waste energy even when there is nothing wrong? This is where power factor comes in. Power factor is a unitless number that tells us how efficiently the electricity is being used in an AC circuit, like in a building or an electric motor. It is the ratio between true power, the power that does the useful work, measured in kilowatts, and apparent power, which is the total power supplied. Think of it like a schooner of God's nectar, cut and dry. The beer is your useful power. The foam on top is wasted power, the energy that doesn't do any positive work. A full schooner of beer with little foam means there is a high power factor, and lots of foam means there is a low power factor. There are two types of power factor. The first being lagging. Motors and transformers create magnetic fields that delay the current. As shown in the diagram, this delay makes the current lag behind the voltage, thus having a negative effect and lowering the power factor. This is called a lagging power factor. While if there are capacitors in the circuit, the opposite occurs. This is due to the current needing to initially charge the capacitor before the voltage can flow through. This causes a current to lead the voltage, and this is called a leading power factor. A bad power factor can have negative effects. For example, a poor power factor can have a significant impact on the electrical grid's capacity. This is because a low power factor means more current has to be sent to deliver the same amount of useful power. This extra current being sent causes voltage drops, wasted energy, and overheating in the power lines. This causes negative effects for power supplies because they must handle more current to produce the same output. Power factor can be improved several different ways. It can be fixed by adding capacitors or inductors to balance the system out. By doing this, it allows for the voltage and current phase to line up again. This improves the power factor and reduces waste energy and load on the electrical grid. The main points to remember is that a high power factor equates to an efficient system, whereas a low power factor causes wasted effort and higher costs to occur. Power factor is a unitless number, but it has a massive effect on the electrical